Okay, this is exam 2 for Physics 101 for fall 2020. Here I'm kicking a soccer ball and it's going from ground level to ground level like this. And it has a speed, initial speed of 20 meters per second at an angle of 30 degrees. And I want to know what is the ball's maximum height. So in order to find this, I need to recognize that Vy at the top of this trajectory is 0. So Vy I know is V naught y plus Ayt, and then I have 0. V naught y is going to be 20 times sine of 30 minus, or plus rather, minus 10 meters per second squared times t. If I solve that, I get 0 equals 10 minus 10t, or t equals 1 second. So it takes 1 second to get up to the top of the trajectory, and then I say y is equal to v naught y t plus 1/2 ayt squared in order to find the position at a time of 1 second. So this will be 20 sine of 30, which as we already know is equal to 10 times 1 second minus 5 times 1 second squared. So that's going to be 10 minus 5, or 5 meters. So A is the answer. Same question, what is the ball's velocity at the top of its trajectory? Well, at the top of the trajectory, I only have a velocity in the x direction. So I want to know what is Vx equal to, and that's going to be V naught times the cosine of my angle, which is 30 degrees. And V naught is 20, cosine of 30 is 0.87, so I'll do 20 times cosine 30, and that's equal to 17 meters per second. So A is the right answer. Number 3, a cannonball is fired horizontally at 10 meters per second from a cliff that is 80 meters tall. How far from the cliff does it land? So we have something that looks like this, where I have an object that goes off, and I want to know what is this distance x. First, in order to find that distance, since I know that x is equal to vxt, I already know Vx. Vx is 10 meters per second because this has entirely horizontal motion. So I need to find out what is t. In order to find t, this is where I'm going to start. I know that this thing is dropping from 80 meters, so it's really just asking the question of how long does it take to drop a distance of 80 meters. So I say y is equal to v naught y times t plus 1/2 ayt squared. V naught y is 0, so that term goes away. I have negative 80 because it's starting at y equals 0 and it's going down 80 meters, so it's negative, equals to half of negative 10, which is minus 5 times t squared. 80 divided by 5, what's that, 16? So t is equal to the square root of 16, or 4 seconds. Now, I know what Vx is, so I can go back up here and have 10 meters per second times 4 seconds, or 40 meters. So D is the right answer for number 3. Kick a ball from top of a cliff that's 100 meters above ground level. The ball has an initial speed of 25 meters per second and an angle of 30 degrees. What is the y position of the ball at t equal 5.4 seconds? Well, the key here is that I give you the time. And since I've given you the time, it makes this problem a lot less complicated because I can just use this parametric equation, y equals v naught yt plus 1/2 ayt squared, in order to find what is the position at t equal 5.4 seconds. Otherwise, I know everything that I need to find y. So v naught y is 25 meters per second times the sine of 30 times t, which is 5.4, minus 5, that's half of negative 10, times 5.4 squared. And that'll give me my y position at 5.4 seconds. I get minus 78.3, and this problem is a little bit more complicated because the y position is negative, and you really have to think about this just a little bit because look, I have this cliff right here and I have this ball and it's going off like this, and when I find that it's at minus 78 meters, what that means is that this is y equals 0, and so 78 meters is down here, or negative 78. So it would be 78 meters below the edge of the cliff, but that's not what this says. This is above the edge of the cliff. And so this is kind of like in lab when you were doing the shoot the monkey experiment, where you're trying to shoot the ball through the ring. In order to find the position of the ring, it was easier if you subtracted the overall, the height of the initial height of the ball minus the amount that it drops. And so what you do here, since I know that this distance is 100, I say 100 minus 78 is equal to 22 meters. And so it's 22 meters above the ground level. And a lot of you put A there, and you know, that's the next best answer, but you have to be careful in reading those extra descriptors and find that it doesn't say above that it's not above the edge of the cliff. That would be like way up here somewhere. I don't even know that it even goes up that high, but it's actually 78 meters below the edge of the cliff, or 22 meters above the ground level. Okay, what is the magnitude of the ball's velocity at t equal 5.4 seconds? Well, we need to find Vx first. That's going to be V naught times the cosine of the angle theta. V naught was 25 times cosine of 30. And that's 22 meters per second. That doesn't change. And then Vy is equal to V naught sine of theta, that's V naught y, plus AYT, which is going to be 25 sine of 30 minus 10 times 5.4. So this is going to be 12.5 minus 54. I'll do 13 minus 54 is minus 41 meters per second. So that should key me in actually at 5.4 seconds that my object is now coming down on the apart from right here, that's on this side of the motion. Now, in order to find the ball's velocity at that point, I would say the square root of 22 squared plus 41 squared. Because it's squared, that negative just goes away. Negative 1 times negative 1 is positive 1. 22 squared plus 41 squared, square root of that is 47 meters per second. So D is the right answer for number 5. So the previous question was the x component of the ball's velocity at t equal 3.2 seconds. Well, I've already gotten that, right? Because the x component of the velocity is 22, and it's always 22. So E is the right answer for number 6. Projectiles launched horizontally from a cliff. Which of these graphs represent the x position as a function? So this is where it goes like this. Initially, it has, oh, I see, this is the x position. This object, the slope of this x versus t graph, should show a velocity that is constant, a velocity that is unchanging and positive. So it should look like B. Soccer ball is kicked with an initial speed and an angle theta. What is the following statement? It says true. The velocity at the top of the velocity of the ball at the top is 0. That's not true. Vy at the top is equal to 0, but Vx is definitely not equal to 0. The horizontal component of the velocity is greatest at the beginning. Again, not true because the horizontal component is always constant. The acceleration is not positive. In fact, the acceleration is always minus 10, and the ball's speed increases as it travels upward. That's not true. In fact, the ball's speed starts out big, it gets smaller, and then it has its smallest value at the top of the trajectory. Again, the x component is always the same, but because the y component is decreasing as it goes up, that means that the overall speed is also decreasing. All right, projectile is launched from the ground at an angle of 30 degrees. At what point in its trajectory does this projectile have the least speed? Okay, at the least speed is at the highest point, and for reasons that we've already said in the previous question. You are shooting a projectile with a speed of 50 meters per second, an angle of 55 degrees. What can you do to increase the vertical range? Two things that you can do. You can increase the angle and increase the speed. Either one of those will increase the vertical range of that object. All right, a hunter is shooting at a target that is falling vertically. When he shoots, he should aim. He should aim actually straight at the target, and then as the target falls, the bullet from his gun will also fall, and they will meet at the point where they'll meet at that point. So you should aim directly at the target. Which of these projectiles remains in the air for the longest amount of time? It's the one with the maximum vertical distance, so A is the right answer. Book is lying at rest on a table. The book will remain there at rest because, okay, an object will stay in its current state of motion, whether it's moving at a constant velocity or stationary, unless a net force acts upon it. So if it's not moving at all, that means that there are no net force acting on the book. Remember, the net force is the sum of all the forces. It doesn't mean that there are no forces. If this is my book, I have lots of forces acting on it. I have my normal force, I have my weight, I might have some other forces acting on it, but it just means that there is no net force acting on that object. An object slides down an inclined plane, as in this figure. A frictional force acts upon the block. Which of these statements is true? Okay, the frictional force will increase if the mass is bigger. That's true, because if the mass is bigger, that means that the normal force will go up. The block accelerates at a rate faster than g. That's not true. On an inclined plane, it will accelerate at a rate less than the acceleration due to gravity because of the inclined plane. The frictional force acts in a direction down the inclined plane. Not true. It acts actually upward in that direction, and the frictional force will decrease as the block's speed increases. That's also not true, so E is the right answer. Person in an elevator accelerating upwards, how does the person perceive their weight? They feel heavier. Card is on a frictionless table. Once the card has been pushed and released, what will happen to it? It's frictionless, so it will continue at a constant velocity, which is usually larger, static. An object is moving at a constant velocity. Which statement is always true? If it's moving at a constant velocity, that means the acceleration equals 0, so the net force on the object is 0. That's a lot like the question I did before. It might go away, I might keep it, we'll see. You apply a horizontal force of 100 newtons to a 25 kilogram mass and it accelerates at a rate of 2 meters per second. What is the coefficient of kinetic friction? Look, if I were to apply 100 newtons to a 25 kilogram object, I would get an acceleration equal to 4 meters per second squared. But I don't. I get an acceleration of 2. That means something else is going on here. So I have this object. There's my weight. There's my normal force. There's the force that I'm pushing with, which is 100 newtons. By the way, this is 250 newtons. And then I have some kinetic frictional force. Now, since there are no other forces in the y direction, I know that my normal force is also equal to 250 newtons. It's the same as the weight, only because there are no other forces acting in the y direction. So that tells me then that I can find, I'm looking for mu, and I know that mu is equal to Fk divided by the normal force. So I have my normal force, 250. Now I need to find what is Fk. So I can look at the sum of the forces in the x direction. That's 100 minus Fk is equal to 25 times 2. 25 kilograms times 2 meters per second squared. So Fk is equal to 50 newtons. So I have 50 over 250. That goes away. So that's equal to 0.2. So number 19 is A. 80 kilogram block is suspended by a rope in an elevator that is descending at 4 meters per second squared. What is the tension in the rope? So it looks like this. I have a weight of 800 newtons, and I have a tension. I don't know what that is, but I know that it's accelerating at negative 4 meters per second squared. So I say Ft minus 800 equals m, which is 80 times negative 4. So Ft equals 800 minus 320, which is 480 newtons. So this object feels lighter as this elevator is going down. 2 kilogram mass is pulled up a smooth incline by a rope, so it accelerates at 1 meter per second squared. The rope is parallel to the surface. If the incline is 30, what is the tension in the rope? So I'm just going to draw my forces. This is my tension right here. This is my normal force. Do I have friction here? Nope, no friction, so that makes it a little bit easier. This is my weight. And now I'm going to redraw that so that I have my coordinate system there, and then I have Fn, I have Ft, and then I have Fw cosine of 60 and Fw sine of 60. I'm looking for the tension in the rope, so I can look at this sum of the forces in the x direction. That's going to be Fw cosine of 60 minus Ft will equal to max. And it's where I have to be careful, because notice here that AX is equal to -1 meter per second squared. So I have to be really careful about that. Fw cosine 60 is going to be 20 newtons times cosine of 60 is a half, minus Ft equals 2 kilograms times -1, which is my acceleration. So this is Ft will equal to 10 plus 2 or 12 newtons. I might go back in there and add 8 as an option as well, just to make sure that you're certain about that it's clear. Let me make a note about that. All right, number 22. You push a 2 kilogram mass with a force of 80 newtons, as in this figure. The coefficient of kinetic friction between the block and the floor is 0.1. What tension is required to accelerate the block at 5 meters per second squared? So I'm just going to draw my coordinate system over here, and then I'll draw all the forces that are acting upon it. So I have a force here. That's equal to 80. I have a weight. That's equal to 20 newtons. So I have 100 newtons going down. And then I have a normal force, which you might already be able to tell, hey, that's going to be 100 newtons. I have a tension in this direction. And then I have a kinetic frictional force in this direction. So in order to find out the tension, I need to know what is the kinetic frictional force. But to find the kinetic frictional force, I can say that Fk is equal to mu k times Fn. And then in order to find Fn, I can say the sum of the forces in the y direction is equal to 0. So that means that Fn will equal to 80 plus 20 or 100. Then Fk is going to be 0.1, that's mu, times 100 newtons, that's Fn, or 10 newtons. So that is my kinetic frictional force. It is 10 newtons. And then in the x direction, I'm going to have Ft minus 10 equals the mass, which is 2 kilograms, times the acceleration, which is 5 meters per second squared. So Ft will equal to 10 plus 10, which should be 20 newtons. Okay, so the answer for that is, for number 22, is C. All right, so the block in the previous question, what is the force due to gravity acting on the block? Well, that's hopefully that was easy, because it's 2 kilograms, so it's 20 newtons. Consider this figure for the next two questions. What is the normal force acting on the block? So my normal force is here. I have my weight here, and that's really all that I have. Although in the next question, I'm going to see that I'll have frictional force. I'll go and put that in here just so we have it. And now I'm going to draw my coordinate system. We're getting all sorts of colors here today, aren't we? This is my normal force, Fn. This is going to be Fw cosine of 60. This is going to be Fw sine 60. And then up here in this direction is going to be Fk. Pause for just a second. I'll continue. So Fk. So here, Fn, I'm looking for the normal force. I know some of the forces in the y direction for an inclined plane is always 0. So Fn minus Fw sine 60 equals 0, or Fn equals Fw sine 60. That's going to be 100 times 0.87, or 87 newtons. So 24 is B. So to the bottom of the previous question, if the coefficient of friction is 0.2, what is the acceleration? So I already know Fn, so I can figure out Fk. It's going to be 0.2 times 87. That's 17 newtons. Now I do the sum of the forces in the x direction. Fw cosine 60 minus 17 equals to MAX. And MAX is what I'm looking for. So let's just put in our values here. This is 100 times cosine of 60, which is 50, minus 17 divided by the mass, which is 10 kilograms. And that's going to equal to AX, which is, 33 over 10, 3.3 meters per second squared. You have an object with a mass m, and you exert a force F on it, giving it an acceleration a. If you make the mass smaller, but you keep this force the same, what happens to the acceleration? Well, if this gets smaller, then the acceleration will increase. So this figure, the block is stationary. Which of the following equations is correct? Well, I've already done this, so actually I can just look at this diagram, because this is the one that I've already drawn, and it's the same diagram except here this is going to be Fs instead of Fk. So Fw sine 60 minus F cosine 60. No, that's not right at all. Fn is equal to Fw. That's not right either. Fw cosine 60 plus Fs, that would have been correct if this was a negative. And Fw cosine 60 equals Fn, that would have been correct if this was sine. So the answer there, of course, is E. And then who's my favorite student? These are some of my past favorite students. Although all of my students, as you know, are my favorites, so the answer is D. All right, tough test. Good job.